afternoon, everyone. Thanks for jumping on today's webinar. My name is Tim Nordvedt. I am a senior manager of the solutions architect team here at Synack, and we've got a fun conversation lined up for today. We're really going to dig into this whole buy versus build topic. We're going to, start with Dan, talk about how Dow ended up choosing Synack for penetration testing, kind of how they went the buy versus build route. And then we're going to flip it over and kind of talk with Mark about how Synack built its own AI pen testing engine, or Synack Autonomous Red Agent, or SARA as most of us call it. But before we dive in, some quick housekeeping. If you have any questions today, feel free to drop them in the chat and we'll do our best to circle back to as many of them as we can and maybe follow up afterwards if needed. But before we get into anything, let's introduce our speakers today. Dan, you want to kick things off and give everyone a quick intro?
Sure. Dan Lacher at Dow, cyber engineering team leader here. I've been here for 17 years and 8 years in the cyber area.
Cool. Thanks, Dan. Mark, over to you. What do you do and who are you?
I'm Mark Kuhr, co-founder and CTO here at Synack. Run all things product and engineering here. I've been pretty involved in a lot of our AI build-out and initiatives with Sarah, as you mentioned. I do refer to her as Sarah. I give her, I guess, a name there that would be familiar to humans, even though we do see it as an acronym as well.
Thanks, Mark. Yeah, looking forward to digging into that in a little bit. So again, my name's Tim. I'll be steering the ship today as we kind of have this conversation, try to get both sides of this buy versus build debate. But Dan, I'd like to start the conversation with you. So for a minute, I'd like to go back to 2022. That's kind of when we started this partnership with Dow and Synack. Kind of a multi-part question to kick things off. What was going on several years ago at that time? Kind of what problem were you trying to solve, and maybe what else, what other alternatives did you look at before you landed on pursuing this partnership with Synack?
Yeah, we had had our own internal red team with starts and stops as people had exited the company or transitioned roles. And we're really looking for a value solution to continue to give us compliance and really to start to go after some of our highest value web-facing assets. As we started to look through those, we ended up with Synack. Have had you guys on board since 2022, like you said. And at that time, we didn't have an internal red team. And so we really had to build an engagement with someone that we could focus on. And we were really looking for the continuous coverage options that Synack provided us. The point in time, we'd get the results and then turn a blind eye to it for several months and then come back at it, maybe once a year. And it was just something we really wanted to close the gap on with the continuous coverage option.
That's what we're hearing a lot, kind of the point in time transition to a more continuous ongoing assessment. It's the point in time, the second you get the report, it's out of date at that point in time. So you mentioned the red team kind of had some starts and stops, and there wasn't like an official red team when we started. Kind of fast forward today, like how has that changed and evolved over time, and what does that red team look like today?
Yeah, we have rebuilt our internal team. It's small at this point, but we are using them for a lot of internally focused engagements and then building out structured engagements to hand to Synack, as well as our internal teams are the only ones that know what assets we need to be going after. So it's really helping drive and direct where we're putting the Synack power to. Externally as well as soon to be internally on our network.
That's great to hear. So if I can make a kind of follow up on that, it sounds like buying and kind of partnering with Synack didn't necessarily sink the need for internal red team and actually kind of leveled it up. Would you say that's correct?
Yeah, I don't know who gave me this term, but I really see it as a force multiplier, right? I have a small team, but when I can engage with Synack, I have the almost unlimited scale with Synack to use as that force multiplier for my team to just go across assets at scale and speed and velocity.
So kind of digging in a little more today and kind of aligning with the conversation we were to talk about, let's look at AI pen tests. I know that caught your and your team's eye at some point. I'd like to dig into there a little bit. I know from talking to some of the people on the account team at Synack here that supports you all, your goal was never to build like a full end-to-end AI pen testing solution. So talk us a little through that thought process. Kind of, did you look at other AI pen testing vendors out there? Kind of, how did you decide on what you were going to own yourself versus outsource? Kind of, where did you end up with things, and what does that look like today?
Yeah, there's there's a lot of them on the market. We've looked at a few, did POCs and proof of values with a few of them, brought in these tools that are really, turn them loose, they go off, they assess. A few of the better ones are starting to learn to chain results together, um, and then kick out a report at the end. Again, those tools give us that sort of force multiplier effect because we have to have our humans directing where we put those tools, and then digesting the results afterwards. Um, and like I said, looked at a few of them, didn't go with them, and then now that we've restarted the red team, we've looked at what it would take to just build that all ourselves. It's a lot of tokens and a lot more engineering manpower to rebuild that all from scratch versus have an entire engineering arm at a trusted vendor that builds it, and we can use the output from there.
I think it's a really interesting application of kind of humans and AI working together in those engagements as well. Finding ways where you deploy the AI agents to go, maybe do things that are broader, maybe not as in depth, and then you use the humans to guide and do follow on testing with things and go a little bit deeper. Is that kind of how you're seeing humans and AI working together, Dan?
Yeah, it just gives us that ability to, again, we have to have the humans directing them to start with. Um, the agents never sleep, so we can get the scale and the speed at that. But the results coming out of that, we can't just kick those off to our support teams right away. We got to put that human back in, look at the results, see what actually is meaningful. And every one of these AI platforms for pen testing don't know the additional defense and depth layers we have of, right, there might be a vulnerability there, but is it really exploitable, or do we have other mitigating factors there? And that human that knows that is very helpful.
Yeah, I think that guidance and that context that the internal team can give the AI agents just super crucial in the way it evaluates potential vulnerabilities and also the way it hunts. So I think that context mismatch where if you have no AI with AI without context, it's gonna get lost in the sauce a bit. And so I think it's important that you have that internal documentation in the same way you would onboard a human pen test team is the same way you want to onboard an agent pen test team.
Kind of building on that a little bit, Dan, kind of what you and your team are building. From what I gather, is it you're building something kind of focused on like the external attack surface, so you have better data to feed into the testing? Is that correct?
Yeah, we've really taken on the Synack in multiple pieces that is offered there. One, initially we just put the continuous testing against our highest valued external assets. Ensure we had coverage, ensure we can find and fix at speed and scale. But we have immense breadth, and the breadth that's facing externally grows at a rapid pace. So what we've started to do is then take our internal teams and through automation, look at those things that we expose and hand them off to Synack in near real time, so that we can turn around and have Synack come back at those assets with the scale that Synack has for that. Right? You could think of engineers exposing an S3 bucket or blob storage, and as new assets are delivered to the internet, the ability to scrape that out of our cloud and feed it back to Synack at near real time so that you can turn around and give us the results back on the asset, are where we've built some automations with our internal team to do.
Yeah, that's pretty cool. That's a really great way to use the Synack platform and pushing data to it, getting the testing exactly what you need based upon the attack surface. That's a really intelligent way to apply the tech.
Mark, maybe you can add a comment here because I think this speaks to why we built Sarah in the first place. It wasn't a matter of trying to build the shiny new object and just have a cool new tool. What Dan just spoke to is a problem we see with a lot of customers where the attack surface is growing faster than most security teams can keep up with.
Yeah, it's a common problem. I mean, you try to task this to human pen test teams with all these changes, they're going to drown in all the changes. They're going to drown in the number of vulns. And so if you hand those to AI agents and especially ones that are built to scale out and into teams, you're going to end up with a lot of horsepower you didn't have before to go dig into those issues, figure out which ones are actually exploitable, suppress the ones that aren't, and then have your human team, your remediation efforts focused on the actual issues that adversaries could exploit. And this is how we clean that signal up and get rid of the noise. And it's just really critical that we have a platform where that humans and AI agents can collaborate together, sharing information back and forth, sharing context, really move the ball forward where these agents can be supporting actors to the human teams and really bolster their capacity.
Absolutely. Yeah. So one last question for you, Dan, before we kind of dig in with Mark and kind of how we built Sarah. So when you look back at 2022 and maybe even now kind of partner with us with Sarah, like what was it that about Synack that kind of clicked as we're someone that, you can move forward with? Like what mattered most to you about the team, about whether our test and our platform? Maybe speak to that for a minute.
Yeah, I mean, it comes back to, and this is what brought us to you guys in the first place. Well established, vetted researchers was the key piece there. As we were going to give you access to our most valuable assets, we needed the security researchers to be very well vetted. Um, a, a company that is backed and reliable. And then as we moved into Sarah, it's the human in the loop aspect, and I'm sure Mark is going to touch on this, that even after the AI goes out and looks at it, finds it, tries to exploit it, before I see it, then as a customer and I get the reports back, I know that a human has vetted exactly what the AI has found. And it's at that same level that I get from human validated testing as well.
Yeah. Yeah. You don't want to waste your time chasing, AI generated slop and false positives. I think that's where people are getting a bit lost now, is putting agents on things without any human in the loop can be quite noisy. So it's good to see it all come together into one flow where you've got this quality verification, and frankly, a learning loop where we're getting smarter and smarter on making the AI agents better at discerning exploitable vulns from ones that aren't. And then more specifically, getting to the point where your own acceptance rules, for your business, you may find certain things in certain areas of the network it's an acceptable risk, and that's okay. And so that kind of context on your business and the way you run it and whatnot needs to come into the agent decision making process.
And I think that's a great setup to kind of transition and dig a little more into Sarah, Mark, and take us through the build process. When we talk to people about agentic AI pen tests, and their mind jumps straight to the models. So
Yeah.
maybe give us your perspective on when you looked at the models for Sarah, kind of what your thought process was, and maybe what some of the trade-offs were, and explain some of that.
Yeah. I mean, the models do a lot of the thinking and the reasoning in these systems, but they're not the whole picture. A lot of this, delivery excellence comes from the harness that you put around the models. And that's really, really key. And we've run experiments where we've taken the base models from the large frontier labs and also the open models that are floating around, and just said, hey, here's a prompt, run a pen test, do this thing against this lab, and then compare that to the harness wrapped model, and the performance isn't even close. The harness really makes a big difference because it guides the model's decision making criteria. Whereas the models are getting smarter and smarter, and I think we will see that over time. The harness is still very critical, and you can see this in other areas too. If you look at software engineering, for example, and follow developers who are using this agentic coding for their daily tasks, just not having the right context for the problem creates really sloppy code. Not having the right rules for the agent on how it writes code also creates some slop. So it's really important in any of these domains where we're applying these agentic systems and these models to get the harness right for your particular use case. And Synack has done that with Sarah by really learning on all the pen tests that we do, seeing how it performs, seeing would it make the same decisions that we would make about a pen test, about a particular vuln, about a particular attack surface, about a particular type of fingerprint that we're seeing in the scan. So we're really digging in on the particulars of how a human pen tester would go after a target and bringing that into the harness. And so it gets better and better over time. And that isn't requiring anything at the model layer. You can extend the models, and you can make the case that yes, the future will be custom models, and we're going to build our own models, and we have experiments in that vein as well. But that's a very large engineering effort in itself to code your own model up and get that prepared. And so I think this build versus buy discussion, people quickly get to a level of technical complexity where they're just not comfortable anymore. And it's like, wow, I really bit off more than I can chew with this. I'd rather just outsource the building of this to somebody else and let me benefit from the things that my business needs, which is a more scalable solution for pen testing, or a more scalable way to go through all the vulnerability findings from the scanners. Whatever the problem is, let your business focus on that problem and procure a solution to fix it. Of course, I'm biased in that because we make one, but the point is, it's more difficult than people realize to build one of these agentic pen test capabilities. And you can try it. Go into Claude Code and say, build me a pen testing agent and framework, and it will build you something. It will not work the same way human pen testing works. Promise you that.
So you referenced experiments in there a couple times and kind of monitoring some of the early models. Like everyone's favorite topic when you talk about this is benchmarking. So maybe take us back to how you first looked at benchmarking with Sarah and some of the early labs, and why maybe that approach ended up being a trap.
Yeah. The labs are interesting, and you can get great, amazing results in labs. And a lot of the labs are designed to be simple capture the flag exercises of, I'm going to build a small app. It's going to possess this particular cross-site scripting vulnerability, and the model must, navigate through the pages and send a particular payload to exploit it. And then you capture the flag. There's lots of those floating around. Unfortunately, those types of labs, they don't represent the complexity of the real world. And so when you compare how your agent performs in the labs versus real world against enterprise apps that have real logins, real complicated workflows, a lot of graphics, different things like that, it's not going to be the same. And so it really breaks down. If you built based on lab environment, when you get to the real world, it's not going to perform the same way. And so that's a trap a lot of people fall into. And so, this is an area where I think we have an advantage as a builder, is we see lots of different types of apps, and we see lots of different complexities out there in the enterprise space, whether it be network appliances and devices that behave differently based upon their fingerprint, based upon their OS version, or we see apps that, are frankly just all sorts of varieties of apps, all sorts of different backend web technologies, versions of JavaScript, you name it. The complexity and the randomness is quite huge in the app space. That's where you really got to cut your teeth when you're building the harness, is get that exposure and bring those learnings back into the harness.
Yeah, you mentioned kind of the randomness there, and kind of Dan, back to you. You kind of talked about that freshness gap earlier and how you're working on making sure the platform near real time knows what assets show up. Does that sound kind of like the real world messiness that Mark's talking about is what's showing up in the labs, not mapped in production?
Yeah, absolutely. I mean, we have lots of smart engineers that are doing amazing things here. Um, and the speed at which they want to move, and again, even internally with AI, the speed at which our engineers are moving, it's just that ability to cut down on and catching it earlier before we get it to production is where we're using it. um, and I don't want to turn my AI or red team into AI masters, right? We don't need to go build our own models. And to Mark's point, we don't need to every 2-3 months figure out what new frontier model is going to accelerate us faster. Um, it's fun to go do that in my home lab, but I don't need to be doing that at production and enterprise.
And it's kind of back to what Mark said, do what you're good at. Dow, you are a chemical company, focus on that and securing that and kind of partner with someone like Synack that we have our expertise as well.
Yeah.
So, Mark, you kind of talked about the difference between Sarah in the labs and then actually once we got out in the real world in production. Maybe talk about what it actually took, kind of making that transition and making Sarah ready for like actual customer environments towards production. Like, well, what type of engineering work? Like, what did you have to do? Maybe lessons learned from that.
Yeah, I think one of the things that we learned quickly is that the guardrails process needs to be fairly rigorous. There's lots of stories on the internet now of agents making strange decisions to, delete random directories and delete files in production. And the latest one with OpenAI and Hugging Face and the model deciding it should break out of its sandbox to get the key to the lab tests. And one of the things that we ended up doing with Guardrails is adding a classifier at the time of execution. And this is not something we needed really in the lab environment, but when we got to production, there were so many different avenues to go down and so many different attack paths to try. The creativity of the models, while not as creative as a human, they're still pretty creative on how they want to circumvent and achieve the goals that you give them. And so we ended up adding a pretty rigorous guardrails stack where everything has to run through a specialized risk classifier that makes sure that we're adhering to the rules of engagement set forth in the pen test. And in a pen test platform like ours, every customer can kind of customize those things. You've got scope rules, you've got things, maybe areas of your app you don't want to focus on, or you don't want to follow certain flows, and you're like, hey, ignore this area in production or whatnot. All those rules have to be enforced at runtime across a swarm of agents. And so our guardrail system handles that by classifying the commands in real time, really quickly, and allowing the agents to continue mission, while also making sure it's production safe. So that was a really fun engineering project.
You mentioned kind of the swarm of agents. I've read this multiple times that this is kind of the direction that the industry is moving. Like, I read an Anthropic report where on their own end, they compared one kind of lead fully autonomous agent against a bunch of smaller sub agents led by one orchestrating agent. And the swarm agents beat them 90% of the time on the internal benchmarks. And
Yeah.
Microsoft, same thing. They built a system with over 100 specialized agents and found that it beat both Anthropic and OpenAI's frontier models on all their cybersecurity benchmarks with the swarm approach versus the single.
Yeah, and I think that's a good approach, to take. I think we're moving to a place where you're going to end up on the continuous tests, like Dan was talking about before. The continuous is the best product, and Synack has offered that, for 13 years that we've been in business, and it is continuous humans for a year on your apps or your infrastructure, and then we rotate those groups of people about every 6 to 8 weeks. The system will rotate and you'll get new testers on those. And I think that's the best way to do security. It has been for the last decade. I think it's pretty rigorous. It's probably the most comprehensive continuous test you can buy on the market. And the way that evolves with agents is really, it's going to be about the same. You're going to end up with swarms of agents and swarms of humans. And the swarms of agents are going to be specialized for their attack surface specialties. And they may use different models. So, what we're doing is looking at benchmarks where, we may do reconnaissance across the target with one agent, and then start to break out specialized attack agents to go after particular things of interest. And those particular attack agents will have skills associated with them of like some of the best hackers in the world. And so they're going to be really knowledgeable about that particular attack vector. And then they're going to be able to go deep with fresh context. And this is where it's starting to touch, context management and how you engineer these things. Because as you run tests, you're looking at lots of data, you're filling up those context windows, and even the top tier models only have about 1 million context window size. And we'll get to 2, we'll get to 3, but it's you get drastically different performance with fewer things in the context window. So I think it's really important to manage that along with the sub agents really well, and fan out and slim down where you need to. But that's really the magic of the harness and how it controls for that. So you get the best performance with the best model, the best harness, the best specialized agent on a particular piece of the attack surface at any given time. And of course, it helps with speed. If you need to execute across a large attack surface, having lots of agents prosecuting the target at the same time is how that's done. And this is frankly how adversaries will evolve. And I think the pivot conversation for this is that the defender has to now deal with, these relatively smart, specialized attack agents coming all at the same time. And I think that changes the defender game quite a bit. And I wanted to get a little bit of insight from Dan as well on how he's thinking about that for his team.
Yeah, that's the interesting side is I also have most of our engineering on the defense piece, and it's how can we use AI to defend against AI? So we have pieces doing that for our own internal use of AI and making sure we have security layers and boundaries on, all of our employees and our engineers using AI at scale. But then how do we get that for to respond at speed? So we are the SOC portion of us of DAO that does response, and our detection engineering is really looking at building a lot of autonomous features there to respond at scale and at speed, because it takes a while to page somebody out and get them up and get them back on a console, where we need to be able to respond to those adversarial threats at machine speed, and then across the scale of our global enterprise.
Yeah, it really changes the game a lot, right? And this speed of execution on the offense is going to lead to speed of execution on the defense. And I think you quickly get to a place where those initial triage decisions and maybe initial defensive actions are fully automated, because there'll be no other way to move as fast as the adversary if we don't.
Yeah, the other part I think there that we're looking at is as Mythos, came out, and as we're looking at these frontier models, and they're finding new vulns that have lived there for, multiple decades, and everyone is going to have access to these soon if they don't already.
Sure.
We can't patch our way past the speed of AI. So we have to come up with the new ways of building the defense at scale and speed, because, I can't, as new vulnerabilities come out on a regular basis, we already struggle sometimes to patch on a monthly cadence. There's no way we can start to patch on daily basis.
Yeah. And at the same time, it gives you some opportunity, though, to take a fresh look at tech debt that maybe you didn't have capacity to take on in the past, with agentic engineering being a way to accelerate our ability to make changes.
As we talk about the speed of the adversary and how they're powered by AI, I think it even digs more into the argument that point in time testing is no longer adequate. Like we've got to we've got to be as fast or faster than the adversary. So Dan, I just want to kind of go back to you again. You talked about how Dow wanted to transition from this point in time to continuous tests, and this was starting before AI was even kind of a factor in the equation. So what was the decision back then to start looking at continuous testing, and why did Dow want to move in that direction?
The continuous testing was just the new way that we wanted to start to look at it. We knew that the point in time gave us just that. That the moment we ended the test and started to generate a report, the data was already stale. The environment continued to change. Our developers, especially for our main e-commerce websites, were continuing to push out new code. And if we only looked at that, level of efficiency once a year, once a quarter, right, we just left the door open to new vulnerabilities for a long time. You're not going to leave your front door wide open all night to. So we just wanted that continuous evolution on our most valuable assets.
No, that makes a lot of sense. Thanks for that follow up. So Mark, I got one more question for you before we start to wrap things up. Kind of Dan touched on this earlier with the token costs and the engineering costs that they wanted to avoid by building their own solution. For customers that partner with Synack and kind of utilize us for our agentic AI solution, what costs are they dodging by not having to build this in-house?
Well, we've gone to a model that's fixed price. So, you've got one price to do a test, regardless of how many tokens are used on the back end. And it's your guess is as good as mine as on how many tokens actually are going to get consumed in these tests. I mean, we can estimate, but each run is a little bit different, and each attack surface is a bit different. So what we've done is we've simplified the business model, so you don't have to think about, well, is this a small amount or a large amount of tokens? Like that's not a decision that most people want to have to make when they want to do a test. I just want to say, hey, I've got this app, I want to test it, and let's get it done. And we give you a simple 2-tier approach, Sarah Pentest and Sarah Pentest Plus, where there's different scope definitions, but it's a simple fixed price to do the test, and we just simplify that whole decision-making process.
And beyond the token cost, I mean, is there an engineering cost customers need to think about when you think about model deprecation, having to retune as models
Yeah.
transition?
I mean, yeah, if you're going to build one of these yourself, I mean, there's a lot that goes into making sure it doesn't go out of date quickly. With each model change, you've got to evaluate your prompts. With each tool update that's in your toolkit, you've got to make sure it doesn't break anything. And there's a ton of engineering that goes into the swarms and how the agents interact at the time of execution as well. How do you orchestrate that? How do you make sure it doesn't get out of control? How do you make sure it shuts down properly? There's all these problems that come up as you're thinking through how to actually execute that kind of pen test at scale when you start scaling out across lots of infrastructure to do it. And then there's also the thing you got to worry about, which is, are you getting the best results from any particular model, and how do you know? At least with Synack, we can see performance compared to what we'd see in human performance, and see how close the agents are getting to human performance on a variety of measures. And we have human review on the detections, so we can also start to feedback learnings on false positives as well.
Yeah, I think that kind of aligns with what Dan was talking about earlier, that, obviously the token cost, that's the cost everyone jumps to, but then there's the staffing. It's one thing to build it, a proof of concept, but actually make it production ready. It's a lot. A lot of the customers I talk to, they don't think through that you have to staff and manage it long term. So I think we can start wrapping things up here. I think Dan, between talking about your journey with Synack and kind of what you're working on, and Mark talking about what we built here at Synack, I think we've hit a lot of the key points customers and organizations need to think about in this buy versus build kind of decision. So as we close out here, I'm going to ask you each a similar question. Dan, I'll start with you. But if there's another security leader that came to you wrestling with this exact same buy versus build call, kind of what would you tell them? What advice would you pass along to them?
I would tell them to buy. On the things you just hit, the engineering effort to have AI data scientists and the continuous engineering effort of just building the scaffolding and the latest models. Let somebody else that has the engineering capacity do that, and turn my red team loose against the things that are really valuable to us. We know our infrastructure, we know our assets. Let us direct. Let our internal team direct, someone like Synack and Sarah at the assets that are most valuable to us. I go back to what I've said earlier. It's a force multiplier for my team, right? A small team that just has the entire context behind it to have this continuous rotating set of highly vetted researchers on target for us.
I definitely appreciate that insight, Dan. So, Mark, same question to you. If a security leader came to you wanting to build a solution themselves, what would you tell them?
Well, I think it's an admirable thing to do, but you got to make sure you're staffed up to do it and you're prepared. And some teams have, substantial engineering resources and budget for doing that. And I think that's a journey you can choose to go down. But like for most things, where it's not core to our business, I think outsourcing is a better approach. And for us, especially at Synack, I mean, when we think about building an agent like this, it's really about trying to take every learning that we can glean from the thousands of pen tests that we do in a year, and bring that into our harness as a way to make the agents more effective. It's really important that we have the ability to spot issues in the runtime at scale. We can fan out agents reliably, and we can deliver production safe agent pen test that is really effective and complements the human tester executions at the same time. Because I think the future of this is going to be man and machine working together, agent teams working with human teams to make continuous testing at scale just the normal way of doing business.
No, absolutely. It reminds me of a recent Forrester report I read where they predicted that companies are going to hold back, the average company is going to roll back a quarter of their AI spend in 2027 once this hype settles and the bills start coming in with the tokens and the maintenance costs and everything. I think the market is aligning with everything you both just said, that using AI to augment, not replace your current program. So Dan, Mark, thank you both for your time. Like seriously, I think it's pretty rare to get an actual customer kind of living this decision right now, and a CTO who's walked the build path kind of in the same table, kind of having this live conversation. Before we wrap up and kind of everyone hops off, if today's conversation got you thinking about where AI can fit into your overall program, we are running a free Sarah pen test right now. We're going to throw up a slide on the screen that gives you a URL you can go to and request that. So feel free to grab that and reach out to us, and we can talk about how AI fits into your overall program. But I appreciate everyone's time today. Thanks for joining our webinar, and thanks for hanging out with us.